Dear students, let us to discuss Wheatstone's bridge. So this Wheatstone's bridge consisting of 4 resistors, like you can say R1, R2, R3 and R4 are connected as shown in the figure. See, let us name these points as A, B, C, D. See, in between B and D, a galvanometer is connected. Let we can say the resistance of the galvanometer is G. And in between A and C, a battery is connected or a cell is connected. So this one is the cell or you can say battery. And this one is the plug key. Okay. When plug key is closed, so what happens? Some current is drawn from the battery, these 4 resistors. See, from this figure, the point A is node or junction. We have already discussed in Kirchhoff's rule. Okay. At the point A, the current I enters and the current is split as I1 and I2. Means some current is flowing through the resistor R1 and some current is going through the resistance R2. Okay. So now at this point we can say current I equal to I1 plus I2. I1 plus I2. Okay. Now come to this point B. Now B is also a junction. So B is junction. So from A to B the current is I2. I2 is the current. So now we can say this current is entering to the node I2. At the point B, again 2 more connections are there. One is connected to the galvanometer and another one is connected to the resistance R4. Let you can say small amount of current Ig is flowing through the galvanometer and rest of the current, that is I2 minus Ig, is flowing through the resistance R4. You can take this resistance R4. I will write R4 here. Okay. I will write R3 here. Okay. So now check it carefully. Again at this point D is also junction. So here current Ig is entering and current I1 is entering. So now current leaving from the node is, let you can say I3, and that I3 is sum of these two. That is one current I1, another current I3. So here the current through resistance R3 is I1 plus I0. So now again come to the point C. Again C is the junction because 3 conductors are connected. These 3 conductors are connected. See here one current is I2 minus Z is entering, another current is I1 plus Ig is entering. So now the sum of current entering to the node is I2 plus Z plus I1 plus Z. So it means I1 plus I2. So I1 plus I2, again the current is I2. So it means the current drawn from the battery is I and that will flow in different resistances and again come to the negative terminal of the cell when the plug key is closed. Okay. So this is the some terms you have to remember here. So now how to solve this by using Kirchhoff's rule? How to solve this network by using Kirchhoff's rule? So from this we can write I equal to I1 plus I2. Okay, and we have already divided the current through R4, that is, we can say I4 as I2 minus I0 only, and current through R3, let me can say it is I3, and that is equal to I1 plus I0. Okay. So now let us to choose two loops. Let we can apply Kirchhoff's voltage rule to the loop ABD. This one is the ABD. Let you can say this ABD like this. ABD. So try to write the sum of EMF plus sum of IR equal to 0. Okay, start from A to B. The current is I2, resistance is R. Okay. Next, from B to D, current is IZ, resistance is Z. Next, from D to A, the current is minus I1 because the direction of the current is opposite to the direction of the loop. Minus I1 into R1. No EMF in this loop, so we get 0. Okay. You can call this as equation number 1. Okay. Similarly, applying Kirchhoff's voltage rule to the loop, take another loop. You can choose like this or like this as you wish. So BCD. Okay. So start from B. B will start from the current is I2 minus I3. Then the resistance is R4. Next, this part is over. From B to C is over. Now start from C to D. C is in the D parana. C is in the D parana. Current is I1 plus I3. But the direction of the current is opposite to the direction of the loop. So that is minus, you take I1 plus I3, and resistance is R3. Resistance is R3. Next, here minus I3 into G because the current is I3 from D to B. And the resistance is Z, and that because of the direction you have to write it as minus Ig into Z equal to 0. You can call this as equation number 2. Okay. So is it clear how to write the Kirchhoff's voltage rule for the loop? Is it clear? Okay. See, as per the equation number 1 and 2, as the resistance R1, R2, R3, R4 are varies, current I1, I2, even IC is also varies. And you have to adjust the resistances R1, R2, R3 and R4 in such a way that the current through the galvanometer is 0. When the current through the galvanometer is 0, then we can say the bridge is balanced or the network is balanced. See, this is the important term. Okay. The bridge is said to be balanced when current through the galvanometer is 0. That is Ic equal to 0. Okay. So now Now we write 1 into as I2 into R2, this one is 0, minus I1 into R1 equal to 0, or I1 into R1 equal to I2 into R. I will call this as 3. And this second equation we can write it as I2 into R4 minus I1 into R3 equal to 0, because I is equal to 0. Okay, when I is equal to 0, this becomes I2 only, this becomes I1 only, and this becomes 0. Is it clear? So, or we can write this as I1 into R3 equal to R2 into R. Is it clear? Okay. So these equations will get only when I is equal to 0, otherwise we are getting these two equations only. Clear? Okay. So this condition is for the balanced conditions. Okay. So now, okay, I write here. Now you take the ratio of these two equations, equation 3 divided by equation 4. Okay, check the equations carefully. So equation number 3 I will write here, I1 into R1 divided by I1 into R3 equal to I2 into R2 into R4. So I1 get cancelled, whatever may be the value of I1 and whatever may be the value of I2, that will get cancelled. So we get R1 into R3 R2 upon R1 by R3 equal to R2 by R4, or we can write R1 by R2 equal to R3 upon R4. So this is the condition for the balanced network. If the network is balanced, if the Wheatstone's bridge is balanced, so then the ratio of these two equal to the ratio of these two. Okay. So then what is the use of this Wheatstone's network? Okay. First note on this. See, after getting the ratio R1 by R2 equal to R3 by R4, see, if one resistance is unknown, like you can say R4 or R1, okay, among these two, if one resistance is unknown, then how to measure the unknown resistance? So you have to connect one unknown resistance and you have to take three known resistance and balancing the network. So it means by adjusting the value of R2, R3 and R4 to get current through the galvanometer 0, it means that can be detected with the help of galvanometer. Galvanometer is the device which is used to detect the current. If the galvanometer is showing 0 means we can say when the plug K is closed. If the galvanometer comes to 0 by adjusting R2, R3 and R4, then we can say now the network becomes balanced. And if the network becomes balanced, then easily we can write R1 equal to R3 by R4 into R2. So by knowing the values of R2, R3 and R4, and by calculating, by subtracting their values, so definitely we get the value of the unknown resistance. Hence, in future, means in next class, we have to discuss the use of this Wheatstone's bridge to measure resistance of a wire or the resistance of unknown resistor. Okay, so by using this balanced conditions and many experiments on this Wheatstone's bridge, it has many practical applications. Okay, and this question asked nearly 4 to 5 times for annual examinations. This one is very simple. Just you have to apply 2 times Kirchhoff's voltage rule, and this condition is very important. When the bridge is balanced, then the current through the element is 0. Then the equations are reduced to I1 R1 equal to I2 R2 and I1 R3 equal to I2 R4. And by taking the ratio and by simplifying, so we will get R1 by R2 equal to R3 by R4. Is it clear? Okay. So, all students up to update agi notes anna ready kodri. In next week dalli will give the submission date ಕೊಡ್ತೀವಿ. ಆ ಡೇಟ್ಗೆ ನಿಮ್ಮ ಮಟೀರಿಯಲ್ ಎಲ್ಲ ಸಬ್ಮಿಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.